could happen. So let's actually talk about this thing called DHCP next. And this is basically a process where you get assigned an IP address. So the basic idea is as soon as I connect to a network, the network is going to say, OK, you're connecting. You need an IP address. I'm going to give you one. And so that's where that decision is made. So when you go from, for example, Harvard to home, when you open your laptop up again, your laptop is going to try to connect to the network. And the network is going to say, oh, you're not connected yet. You don't have an IP. I'm going to give you a new one that's on my network. So your IP address could change, or it could be the same, depending on kind of what happens there. But you will always go through this process of receiving an IP address when you connect to a network. So for example, if I go to a site like whatismyip.com, I can see what my IP address is. So 140.247.0.35. So is this a public or a private IP address? Public IP address. All right, so that's interesting. But what if instead of asking this random website what my IP address is, what if I actually ask my computer what it is? So I'm back at the terminal, and I'm going to type a command that's basically going to tell me what my IP address is. So now I see this thing here, 10.251.74.63. How about this, public or private? Private IP address. So what does that mean about the IP address that I see here? Yeah, so now we're using NAT. So this is exactly what's happening. My computer has this private IP address, but this site here, whatismyip.com, has no idea. It just sees a public IP address that it can actually respond to. Make sense? So just a quick digression. So we mentioned before that when we were looking at the output of traceroute, we said that, OK, well, I'm going to hit this router, and then that router is going to send along to another router and another router. So how do routers know where to go? Right? If I send a request to CNN.com and it hits maybe a router at Harvard or a router in New Jersey, the router needs to somehow know where to send that request. So inside of a router is this thing called a routing table. And every router doesn't know where every other router in the internet is, right? Because that would be just this huge amount of information that's constantly changing even. So it's not practical for every router to know where everything else is, or else I could probably just send it directly. So instead, what a router does know is not exactly where CNN.com is, but kind of where CNN.com is. So for example, when we look here, we went from Newark to Washington. So Newark to Washington isn't directly to CNN.com, but this router knew kind of the general direction. So now when we say general direction, I mean if I get an IP address that's greater than this number and less than this number, kind of like in this range, then I'm going to send it this way. If I get another number that's within this other range, I'm going to send it that way. So that means that we're not always going to make a great decision, right? The path to Georgia might actually kind of go, kind of in the wrong direction for a little bit, but it's eventually going to get there. And the reason being, it doesn't really matter, if we go a little bit out of the way, because each router doesn't know exactly how to get there. And so that's how we're actually moving requests from router to router. Each router just has this thing called a routing table that says generally, OK, you probably need to go in this direction if you're looking for CNN.com. And so that's why our requests might kind of look in the wrong direction. And as you may see in the problem set, sometimes they will go in the wrong direction across continents, but that's OK. So it gets the job done. OK, so let's now address those questions of how do I get an IP address on a network. So to do that, we're going to use this thing called DHCP. And DHCP is just the name of this process by which I am assigned an IP address on a network. So here's what happens. So I am a computer, and I just connected to this network. And I'm kind of lost and confused, and I don't really know what to do. So I'm kind of like the freshman in college who has no idea where to do. So what does he do? He emails the entire campus list asking where the bathroom is in his dorm. Because he has no idea who to ask, so he's just going to ask everybody. So that computer actually does that. We connect to a network, and I'm going to ask everybody, what do I do? I'm lost. So then we're going to have the nice peer advisor respond, hey, it's OK. I'm the one you need to be talking to if you need an IP address on this network. So this device is going to be called a DHCP server. So again, we have this client-server interaction. My computer is a client, and I need to be served some information by this other machine. So this DHCP server is just a machine whose job is to give out IP addresses on a network. OK, so my client gets back, and I'm feeling really relieved because someone answered me and I can get an IP address and I won't be lost. And so I'm going to say, OK, I now want an IP address. So I'm going to send a message now, not to everyone. I didn't hit reply all and be that person. I replied just to my server, the DHCP server, rather. So I'm going to say, OK, hi, I'm client. I need an IP address. And the server is going to say, OK, I'm going to offer you an IP address. The DHCP server says, OK, I'm going to set this IP address aside for you, and I'm going to tell you what it is. And then only when the client says, OK, I got it, this is my IP, then the DHCP server says, OK, no one else can have that IP address, and you're good to go on the network. So this is kind of the process for getting an IP. It's managed by the network. So as a computer, I can't just randomly say, yep, this is my IP, woohoo. If I'm using DHCP, I actually ask the network what my IP should be. And so this is the process by which I get assigned. And we call this 5-step process here DHCP, where the P is for protocol, which we'll take a look at much more next week. But a protocol is just this kind of set of steps that everyone follows. So no matter what kind of device I connect to the internet, it could be a laptop, it could be my iPhone, if it follows this 5-step process, then it's going to be able to get on the network because it's kind of following the DHCP rules. And so this, when I connect to a new network, I'll go through this process again and get a new IP address. Could be public, could be private, depends on what this DHCP server responds with. Questions? OK, so that's kind of at a higher level, and we'll kind of look at a lower level next week. So here, this is actually an image from a webcomic called XKCD, which is kind of this techie, nerdy comic that's really, really awesome. And what he did was he actually took the time to draw a map of the IP address space. So for example, here, each of these dots represents the first number in an IP address. And then he kind of wrote down what geographic region that number has been assigned to. So for example, if we look over here, we can see this 18 or 17, I can't see, 18. So every IP address that starts with 18.x.y.z actually belongs to MIT, which is crazy because entire continents have that many IP addresses. As we can see kind of over here where it's like Africa, you get one of those, and some other countries get one of those. MIT actually has an entire one. Reason being, MIT was really important and pioneering in the actual development of the internet. And so we'll see more of the history behind that later. But this is basically how now different DHCP servers know what IP addresses they can assign. So basically this organization called the IANA, IANA, Internet Assigned Numbers Authority, sat down and said, OK, we're going to split up this IP address space by geographic region. So this was done a long time ago when the internet was first being developed. We said, North America, you can have all of these valid IPs because we think you're going to need this many. So if we look closely, you can actually see over in the 192 region, kind of in the right-hand side, there's this little dot that says private. And that's because we said that this 192.168 is actually a private IP address. So I'll put this image online if you kind of want to peruse it. But basically, this is what we mean when we say that I get this IP address from a DHCP server. This is how the DHCP server knows kind of what it can assign. It's actually split up by regions like this. And so it's kind of hard to see here, but we'll put this online afterwards so that you can take a look. OK, so now let's talk about the connection speeds to the internet. So we know that we're connected to the internet via our internet service provider. And that means that the internet service provider is going to be the one that kind of controls how fast you can connect to the internet. So we're actually going to be measuring internet connections in megabits per second, which I apologize on behalf of the entire internet that we do this. But we're no longer talking about megabytes with a capital B. We're now talking about megabits with a lowercase b. And so when you see something like 100 Mbps, megabits per second, that's not megabytes per second. It's actually about a factor of 10 less, or 8 to be precise. So here, for example, are a couple of plans. So this top one here is a plan from Comcast, and the bottom one here is a plan from Verizon. So this top one is kind of broadband and cable, and it's actually going to end up being a bit pricier than this bottom one, but that's because the speeds are much faster. So for example, down here, let's say we get a 3 megabits per second connection. So let's say we get this one here. So let's say, how long is it going to take for me to download a movie? So a couple weeks ago, we saw that a movie is about a gigabyte or so. So if we have a gigabyte, then we need to download all of those gigabytes. And we have a connection that is 3 megabits per second. So that's going to mean it's going to take 45 minutes or so to download. So instead, if we kind of bump it up to a 20 megabits per second, so this plan up here is more expensive, but now we get a faster internet connection, and that means we can download that same movie in about 10 minutes or so. So again, if we double that, we can get even faster and faster speeds. So now when you're kind of, if you're ever renewing your internet connection plan or you want to kind of take a look at it, this is what these numbers actually mean now. So when we say megabits per second, you can now kind of translate that into real world things, right? This number doesn't mean it's not a just meaningless number. It's nice to see that 105 is much bigger than 20, but now you can know what it means in terms of actually downloading things. So that's megabits per second, which again is unfortunately not megabytes per second. So these numbers here, they're all carefully worded usually, and rather than saying 105 megabits per second, it usually says up to 105 megabits per second. So that means that you're not always getting this full speed. You're usually getting some fraction of that. There are actually sites available, and you'll do this on the problem set, that actually test how fast your internet connection really is, basically by contacting a server and timing how long it took to get from your computer to that server and doing some magic there. But what your ISPs do frequently do, though, is this thing called bursting. And so rather than always give you 100 megabytes per second, when you start downloading a file, we could say, OK, for the first 10 or 20 megabytes you download, we're going to give you that full throttle connection. So no, we're not lying anymore. So we're going to give you that full connection, but only for about the first 10 or 20 megabytes. So that means that if I'm only downloading small files, my internet's just going to start feeling faster, right? Because that first 10 megabytes is coming in at this extreme speed, and then after that, it's going to start to slow down. So on larger files, which are less common, unless you download movies like every second of every day, that's going to start to take longer. But as you're commonly browsing the internet, it's going to start to feel faster, because your ISP is bursting your connection temporarily. So that's why these tests on like speedtest.net and the other ones that you'll see might be a little bit inaccurate, because you don't know what your ISP is actually doing there. It could be bursting your speed. It could be throttling. You don't really know. So this is just kind of like an approximation of how fast your connection is actually is. So it's not perfect, but it gives you some idea of what's actually going on behind the scenes. So those connections now all apply to wired networks. But at your home or even at work, you probably don't just have a wired network. Unless you plan on hooking like your iPhone up to the wired network, you probably have something that's wireless. So at home, you might have a network that's powered by a wireless router made by someone like Linksys or D-Link. And in one of these this week's section videos, we'll actually see the process of setting up a home network and maybe playing around with some settings and setting a password and things like that. But this router probably uses a standard called 802.11n or 802.11g. So what those are these standards for actually providing wireless internet access. And so each of these different standards has a different speed limit associated with it. So 802.11g, for example, was developed kind of a while ago. It's kind of old now. And that had a limit based on the technology of about 54 megabits per second. So that means that no matter how fast your internet connection is coming into your router, the router can only forward along that data at a maximum of 54 megabits per second. And again, this is like a theoretical maximum, so we're probably getting 50 to 60% of that in the real world, actually. So that means that if you have an 802.11g router, you really don't want to go out and spend $100 a month on Comcast's 105 megabit per second plan, because it doesn't matter. You're going to be pumping in 105 megabits into your router, who then kind of slowly forwards them along to your devices. So on the other hand, 802.11n is just a newer standard. If you buy a router today, it's probably that. And that just has a much higher limit of about 300 megabits per second. Other ones might have higher. And that just means that you can now kind of take better advantage of your wired connection speed. So when you're hooking up your home network, that's just something to keep in mind, that it doesn't matter how fast your ISP connection speed is if your wireless router can't take full advantage of that. So on the side of the router box, you might see that 802.11g or A or B or N, or now we're kind of making new ones. And that just describes basically how fast your router can send information based on how your router is working underneath the hood. So you also, we'll see this later, but you also probably want to put a password on your wireless router. Reason being that, as we'll see in section, it's really easy to actually sniff what's going on inside of a network. If everything's just kind of public and all out there, I can actually, without doing anything really, I can just be on that network and kind of watch all the traffic that's going back and forth. So if you type in your bank account number and your password into a website, and it's just totally out in the open, I can just kind of see that flow through the interweb, and take it, which is not a good thing. So what we can do then is introduce these things called WEP or WPA or WPA2 that are encryption. And we'll see this later when we talk about security and privacy. But encryption basically scrambles the information that's going around your internet so someone can't just kind of look in your window and read it. So the way that this works is we'll basically give some password associated with the network that you might have seen. If you've connected to a network and it asked you for a password, that means that the network is probably using one of these things here, which are just different ways of encrypting information. And only with that password can I actually be able to send information around the network. So that means that without the password, it's not easy for me to see what the actual contents of the information being sent around it is. So we'll talk about that in much more detail later, but these are actually the different ways of encrypting or making your wireless network more secure. So the first of these, WEP, is actually a really bad idea because some smart people figured out how to crack it. So even if they don't have the password in about 5 minutes, they can do the equivalent of get the password and see everything that's going around the internet. So when you set up your home network, as we'll see in section, it's a really good idea to give it a password so that things aren't just kind of flowing around where everybody can read them. So finally, before we take a break, your phone, for example, might not use 802.11n or 802.11g. It might use this other thing called 3G or 4G. So as the HP video alluded to, there's no 5G or 6G, but 4G is really just a newer version of 3G. And again, there are just different speeds associated with these things. So they're going to be much lower right now than, for example, 802.11n. This is going to be much slower if you're on a 4G connection than if you're on like a home Wi-Fi network. So that's what the 3G and the 4G refers to on your phone. So let's take a 5-minute break, and then we'll come back and we'll take a look at domains in DNS instead of IP addresses.